we will again getting an opportunity to look at Six Sigma. I hope you have all got the one cost of quality set of slides I had requested Professor Datta to circulate, and I hope you have already got that. Along with it, I also had requested him to circulate a small exercise type. Hope that all of you have got that. If today we will first look at that cost of quality slides, and then we move on to another set of slides where some other important concepts of Six Sigma are there in that slide. Till now, what we have seen is the main key things of Six Sigma is that there are terms of, if there are, everything hinges on terms. There are some terms which you have seen is the Sigma level. And we have seen the different Sigma level may. These are all figures or numbers which we should try to remember. Moment we say we have had a session on Six Sigma. These numbers are, if I say this number, suppose karo 66,200, I say this number and I say this is the defect count or parts per million, then the corresponding sigma, can any one of you recall the corresponding sigma? 66,200, the corresponding sigma.
Yes, sir.
How much? 1, 2, 3, 4, 5, 6. How much out of this?
3. 4 sigma.
3 sigma.
Ilakya, how much? 66?
4 sigma, sir. 6,200 is 4 sigma.
Oh, 66,000 I said.
Oh, sorry. 66 is 3 sigma.
3 sigma.
Yes. So that means those numbers from starting with 6,90,000 to 3.4, these are the parts per million or parts per million, and then the corresponding sigma level we should try to remember. 6,90,000, then 3 lakh something, then like that, and as you said, the 6,000 something is, and then 233, and then 3.4, like that. So these are the sigma level. And a company which generally it is found that at the 3 sigma level, 1 and 2 is out of question. The company goes. The company's chances of survival in a competitive market is almost nil, if not totally nil. I say almost because India sometimes defies certain truths. So sometimes in India, some companies, you may find, it is such a thing that they are still surviving. Generally, it is found 3 sigma also not at all in a comfortable range. It will also vanish. However, electronic and other products, they simply cannot remain in that 3 sigma. It is the 4 sigma level which companies have to be there, and then 4 to 5, which the number of times which have to improve is an enormous number, and then finally the 6 sigma. And also we will remember that this 6 sigma 3.4 considers a kind, this is a word which we will see in today's slides, which considers a concept of shift. So this word we will see today at some point. This is important. There is a shift which is allowed, which takes place everywhere. A process shifts. So with a given 1.5 sigma shift, the 6 sigma level is 3.4. That is the actual 6 sigma. If there is no shift, then the sigma actually is, the 6 sigma level actually is 2 parts per billion. That also you should try to remember. Only you remember. If it is an absolutely stable and stable process, then there is no shift. Then it is actually 2 parts per billion with no shifting. But usually there is always a shift, and therefore the shift allowed, if considered, is 1.5, and then it is 3.4. And then we had seen DPU, defects per unit, that is another term. Dpmo, what is Dpmo? Dpmo stands for?
Defects per million opportunities.
Yes. And what is opportunities? Where error can happen. Yes, the errors. Where this is also an extremely important funda. Defect and errors hoga to that is known as 2 errors can make one product defective. 5 errors or 5 defects can make a product defective or service defective. So those are the opportunities. So DPMO is defects per million opportunities. And then there is a relationship between how to calculate DPMO and given DPU. And from that DPMO, we come back to we can easily go to the table of Six Sigma and find out the level of Sigma of that particular process. This is how we do. And then we had seen that there are tools available. There are techniques available over the time. They are not only specific to Six Sigma, they were there over the time. But some major tools are there like FMEA, like statistical process control, like 8D approach of problem solving, a very, very fundamental approach of problem solving. Again, you should remember that 8D problem solving was actually developed by Ford, but then there are other companies which have, for example, if Ford is a company from which many, many things were derived, but then equally famous is Toyota. Toyota takes an approach of A3 problem solving. A3, what is A3? What is 8D? 8D means discipline. 8 discipline problem solving. Therefore, 8 steps. So those steps are known as discipline. You cannot solve a problem in an undisciplined manner. So Ford developed that a disciplined problem-solving approach. So this is considered as a tool or technique or approach or methodology, whatever you call it. But without that, you cannot solve a problem. And then maybe a very, very powerful tool known as DOE, Design of Experiments, which is also known as Taguchi. Taguchi was a Japanese gentleman, and this gentleman had created something known as orthogonal array. It is a combination of absolute very statistics and intuitive approach on numbers. Please remember that. This is something within why when later on Taguchi was asked, how did you come out with these arrays? Orthogonal arrays means arrangement of numbers. How do you come out with this? It is absolutely intuitive. So he never said anything, but only said that all these things I learned from India, because he was in India at Indian Statistical Institute, and was a student of Prashanta Mahalanobis. India has got marvelous statisticians, and also currently I think Professor Raju. We have Dr. Raju here with us, but then I think what's his yes, CVR Raju, no? He is our world famous. He is very old now, but he is an world famous statistician. So India has contributed a lot in the field of statistics. And then that DOE is a very famous tool. And tomorrow we will try to see the fundamentals, the approach, what it is all about. If we get a little grasp of what it is, then the rest of it is where we can apply and what kind of a knowledge we should have to apply it, and finally how we apply it. Those are expansive knowledges. Those, of course, if somebody, even by reading, it will sometimes be, it is very difficult to understand those tools. But we are not here to develop that skill. But we must know that these are the tools. So we had seen those tools. So today, since now almost all of us are here now, we will let us go into the very quickly why we are going into cost of quality, because please remember till Six Sigma, nobody was the initiatives centering around quality was not directly looking at cost. Whatever Six Sigma concepts are there, they have been there for a very long time. But what makes a difference is suddenly very clearly establishing the relationship between cost and quality. And if I improve quality, I'm going to save cost. That thing was established. Cost of quality as a subject was developed by Duran, and of course later on by Deming, all of them. And it's a fairly old subject, but it will always remain. India missed that subject. India never taught that subject to its students, be it in the management stream or be it in the engineering stream. And never ever, even in the industry, until and unless the parent company is in Europe or is in America and they were practicing cost of quality, nobody was looking at cost of quality. And today, if you go into our industry, you will find that almost every professional company are trying, only trying to calculate the cost of quality. But that's a good sign. So cost of quality's importance, managers have started realizing and are trying to figure out how much is the cost of quality, because there is a relationship between Sigma and Six Sigma and cost of quality. And that means it shows that how much money I can save if I take certain actions. It is the basis of every managerial actions that are to be taken. So we will very quickly look into the cost of quality slides. It's a subject of matter of its own. People can do research on that. These are because what is the optimum cost when there are two costs which are contradicting another two costs which are in those optimization equation. Everything are there in the cost of quality. Since all these things attract human mind, you find that a lot of research can have started happening on cost of quality, because optimization is something which the word itself is is standing on some mathematical concept, the best. And what is the best? So there are two opposing lines, and then the best line emerges. So we will not. It is very exciting. This much I can tell you. And this is not a very complicated mathematics. It is mathematics, but then it is not that much of complicated mathematics until and unless, as you go doing research and research, then you will your data are there, and today data are there, and therefore many things have started on cost of quality, and many companies are really when they are competing, the competition is extremely tough. Then those companies definitely are trying to understand cost of quality in greater details. Therefore, we now go into the cost of quality. Let me bring those slides, and we will finish it up, and then we will go to the exercise and finish that exercise also. So let me now try to get that exercise. Hey, slides. Visible?
Yes,
Yes, sir.
sir.
Okay. Whatever little notes I will say, Scribble it down. Later on, you have it, but you cannot see it right now, no? When we go to the exercise. Or put it aside in your computer, open up something and put it there. Well, we will fast move into from this. This we have seen. This also, I would now say, we can skip it. We will skip this also. This is a little important. This is important. Always remember what is COQ, which is cost of quality, and that is equal to PAF. P for prevention, A for appraisal, F for two things. One, internal failures, another external failures. These are PAF. So COQ is equal to PAF. That you always remember. You will never forget. PAF, 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 like that. You remember that. And definitions, fine. Okay, these are definitions. Our immediate task is to understand the PAF, P-A, if, and if. So this is certain figures, which we should try to appreciate. That waste means which cannot be used any further. Every manufacturing company has waste. Every semi-service organization have waste, and every service organization have invisible waste, which is a terrible thing. So we know the barber. If my barber creates but doesn't properly trim my hairs, it's a terrible thing which will happen. That waste is, well, I will never come back to that barber shop. So that's the extreme. You can think of a software development of a software, the software wrongly developed. So what havoc it can create. And rejects companies have got testing cost. Companies can compute rework. Companies rework, reject, waste, and sometimes testing cost, as well as these three costs. This and this testing and inspection cost sometimes is difficult, but the rest of the costs companies can arrive at. Recall, how terrible it is. Millions of dollars they happen in recall. A company, you may not heard about that company, but maybe Mr. Professor Raju and Mr. Ravindranath and maybe Anil Kumar also have heard about it. It is known as Firestone. Hey, anybody heard about Firestone?
Yes.
Yeah, that's it. That Firestone company is a famous case when there were accidents taking place in the U.S. highways, and then they started examining and leading to deaths. So they were starting to examine what is going wrong, and then somebody came out with the brilliant thing that it might be the tires. So today, if you know that tires are something when the first such cases of accidents taking place due to tires started happening in the Pune expressway. Later on, it also started happening in Jamuna expressway, and today India also knows there are special tires on, and I think the nitrogen-based thing tires. You have to, yeah, which will run on concretes. Concretes heats are generated very quickly, and then the tire bursts, and then at a high speed you lose control, and then you meet with accident. But all these things were not known when Firestone Company, which was then the world's largest company, and finally a liability case went on. They were told, the court told them that you take back all the tires which you have produced during this period. They did, and then the litigation lingered on for many years, and the final result, such a large company vanished, closed down. So if it is recall, and Toyota, why do these companies, Toyota, Fiat. Name any company, and they all have a very, very robust recall system. And same is the case with the electronic products. So this recall. So all these things are the ones which are visible. Visible. These are known as visible costs. But then they say that there is a massive amount of invisible cost. So these are the invisible costs. Excess overtime. Because why are you doing overtime? They said the company says we have to do overtime. It is nothing criminal to have an overtime, but this is excessive overtime is something criminal because your processes are all fractured processes. Your billing errors. What's there in a billing error? We will rectify it and we will send it. Today it can be sent in a jiffy. But if already that error has to go through some layers, you have a problem. So you have problems. Excessive field service expenses. There is a story, and which is not a story, simple story. It is the story of, there is a company known as, I think the this company is Xerox company, Modi Xerox company. You've heard about Modi Xerox?
Yes, sir.
Yeah. Sir, you know what has happened there? The Modi Xerox came, and Xerox company's contribution to concepts of management concepts are enormous. Those same company came into India, and along with Modi, they set up a plants in India. One of the plants is in Rampur. I used to visit that plant. It's a very professional plant. But then, as you know, Modi companies, the Xerox company, over the years, they said, if there is any problem, we have a very powerful service team, and we will repair it and do not only repair, we will give you back a new one if there is a need be. All those things in place, and they were thinking that they were very proactive. But what was happening? The happening was the revenue from service department suddenly became an important item of revenue earning item. So naturally, what happened? People they in the revenue in the service department started looking at revenue, forgetting what? Forgetting the very principle of management, that the product you service a product means there is a failure of the quality. But then you started competing with the original manufacturing company, your original product, and then the service product. The revenue, they started competing, and very soon the revenue from service department overtook the revenue of Modi Xerox company's manufacturing department's total product revenue. Result, there is no Modi Xerox company now. I hope you can guess where the mistake took place. And such in the management field, such mistakes cannot be, it will never be excused. So it was not excused. You have lost the entire focus. Excessive, and then field service expenses were going up, because you were doing it, and the servicing, the company is sending the field service people. These are classic cases and then the revenue become in their mind, they will charge. ऐसे ही हो गया था. So the main focus on the product quality got lost. Of which company? Xerox, a company which had given so many concepts, including benchmarking. So you start relaxing, and you had it. This is a singular one slide which suddenly brought the whole Six Sigma and cost. This is a Six Sigma company is less than 10% of sales. A automobile company, an automotive component company, it is in the range of 2 to 2.5% of sales. Remember. And then here 2 Sigma is this. In the case of service organization, be it ITES or be it IT or be it a hospitality, hotel industry, it is in the range of 30 to 45% of sales. Imagine in a hotel industry, it is the highest, they say, 45% of sales is on it can go. And therefore that company, that hotel company is also struggling at the level of 2 and 3 sigma level. They never knew. Only now hotels also started some time back. Of course, all BC ages, before Corona ages. That is that period. They were also looking at Six Sigma to plug to all their leaks and everything. So this is from there. And out of the total cost of the different cost, that is PAFI. This is the percentage you should usually many companies exhibit ratios which look like this. And can you make out what is wrong with this picture?
Sir, failure costs are very high, sir.
Failure costs are very high. But still, was that Anil?
Yes, sir.
Still, Anil, you looked at the failure cost, and you see, you with your seasoned eyes, and I'm not, maybe our young friends, let me ask Anil, just for a heck of it.
Okay.
Some of my young friends, you will react when what is concerned in this? Where is the concern? Anything, come out with the concern, or say we agree with Anil, sir.
Internal failure cost is very
high. Dekho, nobody is looking
at prevention. The cost for prevention they are putting.
How less it is.
Very less. They have to improve the cost, prevention cost.
Yes.
That is cost of attaining quality.
Yes. You have to improve. It is Indian companies, it hovers around this.
Yes.
0.5 to 2%. It's too high. We are investing so much of what? So much. We never believe. No? It is a belief, and and since it is deeply ingrained in us, Anil, for just like you, I will also react, and every manager reacts that we must reduce. And then the first thing they would like to hit is this one. We cannot. Because you know why? It is external. So they will have many reasons to say, hey, not my responsibility, not my. It has gone out of our boundary. So this is the terrible fear which starts happening. But first time Six Sigma said, be courageous, take up projects, and these are difficult projects. External parties are involved. These are easy. This is the easiest. See how it happens. Hey, this is how the Six Sigma started happening. Now, what are those prevention? Only 4 slides, just 4 minutes. You try to see and remember a classical 1 or 2 things. What are those? It is also debatable. It is also the debate that this cannot be. I would like to put it there. This is a highly managerial exercise which starts happening, and and my young friends, please again and again sometimes go through this and read some backup things and read the book which Professor Datta has given you. It's a little tough, but read it. Reading a book says the practice has gone, but do it. So what are the prevention? The easiest thing to remember is training. Then another thing to remember is, these are planning, PDCA, planning. If you plan Many of the things will if you plan up for everything, plan A, plan B, like that they do. Now India also does plan A, plan B, and at the highest level, at the government level, they also talk about plan A, plan B, like that. But then basically the nuts and bolts of that planning is still have to be really made strong in the government. But in Japanese company, Japanese company, how do they plan? Let me tell you a fundamental. I got a shock when I was told this. I'm done by none else but the country head of that organization, which is very well known to all of you. That company is a Japanese company known as Panasonic. Quite some time back, I myself will not be able to remember, because when that company, and also these two things you should never, you should just keep in your mind that one is Panasonic and the other one is Honda, and especially the Honda motorcycle. Acha. So in the Panasonic, the head of the country, country head, he told me many years back that Panasonic was making loss, year after year, loss after loss. Naturally, in that discussion, the question came, key, you are doing loss. You are making, every year there is a loss. How? Why? And what is your plan? He said, we are here in a new country. We will understand the culture of this country. We will understand the market of this country. We will understand how to do business in this country. Like that, he responded. And then he said, for 15 years, we have a plan that we can make a loss after 15 years. But on the 16 years, we will no longer make any loss. Exactly that happened. Fascinating. The same thing, the Honda motorcycle company. Today, they were nowhere. They were down in that list of motorcycle companies. This was told by the Japanese country. Yeah. But this Honda was told by my Indian friend, who looks after the manufacturing, supply chain, and all those things. So he had told me long time back again he had told me that in 2000, I forget the year, 2015 or 16, you will see Honda climbing up to which level? Honda gave a tough, is giving which is the largest motorcycle company in our country. Quick, young friends, quick. Motorcycle.
Honda.
Is it Honda? Or is it
Indian company, sir?
Indian company? Is it Bajaj? Is it
Bajaj?
Or is it Hero? Or is it
Hero?
Or is it? Just
TVS.
check it out. Just check it out in the last 3 years. What is happening? Who are the competitors? All these three. The sharpest growth is of Honda. The way it has grown, it suddenly started growing. Amazing. How? Only those are the questions which are to be appreciated. So, planning, there's surveys. Why? Because to prevent something. There's manuals to prevent something. There's detailed product engineering to prevent something. There's job description, and look at it. There's housekeeping. This is known as 5S. This zero defect program. All are examples of actual prevention experts. Then appraisal. I am appraising. Usually the test, laboratory, all those are appraisal. So test, inspection, when I have a process control, when I'm trained, QA personnel को train हो रहा है, when I'm audits, very famous. These are all taking a stock, evaluation, understanding status. Those are, but here also there are reviews. There are reviews, but very specific reviews. You have to be very specific in your company. You will, if the question comes, is it, can I have this here, some review here and some review there? Only when, because if something is in both the sides, there is a problem. Only when, if there is a reason and you know how to make it out, then only you agree. That is how it happens. Or else, apparently, these are, oh, ye to bahut easy cheez hai. It is very simple. The moment you think about anything simple, bas gone. Case is gone. Then the internal failure cost is the actually where you fail. Your substandard products, scrap, rework, reinspection, redesign, anything is the internal failure cost. And all re's are bad. And then what remains is the external failure cost, the recall, the complaint handling, the customer service, errors caused by error, product returned, products returned. Imagine. Now the thing has started. All food products, you can go back to the sellers, whichever departmental stores or anything, and you can still tell them that no, I don't accept it. If you don't, if they don't, you have complaints, things in gradually coming in place. For USA and Canada and Europe, you forget. Our country is now getting is becoming alert to all these things. Especially started with food, pharmaceuticals, obviously, and then there are several others. One of the largest companies, it takes much of time. We will not go. And then this is a very, very fundamental thing, non-value added activities. This is the thing. Process analysis may, all that you try to find out is the non-value added activities, and then you try to do many approaches. But there, many means it is not infinity. It is always a limited number. That is the beauty of it. So you examples that this is another gold mine area for companies to attack. VA, it is known as VA and NVA analysis. It is also written down, and then they say there is a hidden organization in a hidden factory, hidden organization. When you touch the cycle time, this we are not at all touching. We are this moment we touch all this. We are combining Lean and Six Sigma, because this Lean or this approach is known as world-class manufacturing, WCM. So this also as a subject is drawing the attention of universities, and many universities have a full scale classes. I mean units that is known as WCM, world class manufacturing. And of course, the principles are applicable both for manufacturing as well as for service. It is known as WCM. Okay, then the why cost of poor quality, then reporting tool, how do we report? Important, they become important once we know this. Trend analysis, priority analysis, it is an investment tool. Those things are typical management lessons. And then advantages as best way to increase a company's profit, which we have discussed. And the rest of it are all there. And just go through that. Now, this is what is the cost of quality. And now let us quickly finish up this exercise, which we were talking about. This also, I think, is available with everybody. Yes,
Yes, sir.
it is available with everybody. Fine. We give ourselves 5 minutes time and we see that. Analyze the following data. Employee training on problem solving is $25,000. Scrap and rework, $250,000. Reinspection and retest, 180,000. You are disposing the rejects. So you were either auctioning it out or selling it at a very high discount, all those things. But that involves a cost, $100,000. Responsible disposal is a fundamental subject now. Responsible disposal. The Japanese always will look at responsible disposal. We never looked into it. No, just throw it out. Vendor audit, supplier audit, 5,000. Incoming final inspection, $1 lakh. Repair of customer returns, $40,000. Which one we might conclude? Can we what do we conclude? It is given already here. Is it which one is correct? How do you go about? You have to find out, you have to tell yourself, out of only this A, B, C, D, E, F, G, tick the prevention ones, tick the internal failure ones, tick the external failure ones, and find out the total cost, add up the total cost, and find out which one is what, how much. If that is this, then you say the answer is A or B or C or D or even E. This is the exercise. You're given 5 minutes and you start it, and you tell me one by one. I will call out the names and you start telling me. Employee training on problem solving. Elakya, you tell me what is this? Prevention, appraisal, internal failure, external failure. What is this?
It's prevention, sir.
Good, right P. Scrap and rework. Sudarshan, tell me.
Internal failures.
Okay, so write IF. Then re-inspection and retest. Varuna, tell me.
Appraisal, sir. Appraisal.
Varuna, again
Sir,
look at it and tell me. Re-inspection and retest.
The external.
So what it is?
External, sir.
Huh? Hey, somebody else now come out, or are we agreeing with?
No, sir. It is internal failure. Internal failure.
Yes, it is internal failure. Internal. Disposition of rejects.
External failure.
Disposition of rejects.
Disposition of rejects.
External or
External,
internal?
sir. External, sir.
All of us agreeing?
No, sir, it's internal.
Internal.
Okay. Why it is internal?
Because we have to reject what are the disposals, sir, and then we have to give external.
The issue is, now you remember, the issue is, or the funda is, if If it goes out of your boundary, you are no longer responsible for it. And then it creates problem and it is coming back to you. That is external. If it remains within your boundary and you have to do something on that, all the costs involved on that, if the product has failed, that, all inside your boundary, it has not yet reached the customer or the dealer, then it is internal. And if it has gone there and then the problem has started and then it is coming back, and then you are doing work on that, all the cost involved there, it is external. So now what is this? Has the rejects gone out of your boundary? Yes or no?
Yes, sir.
Rejects have gone out of your boundary, or is it still inside your boundary? Conceptually kya hai? Whatever you are thinking.
It's inside the company only, sir. It's not going to go outside.
Is it still inside the boundary, inside the boundary of the company?
Yes, sir.
If it is yes, it is internal failure. Your language also has to be very clear. Yes, everybody understands. It is within. It has not yet gone and then come back like that. If it is like that, then well, there is a problem. Then it is external. Now, only learning from here is now. It is so simply put. There are several things where there is a debate, where people try to push it and say it is not our responsibility. It is not my responsibility. Nobody wants to be willing to take up ownership. And the whole problem starts there. The technical part of the whole thing is very easy, but then management part, it becomes easy. But here the answer is if. Vendor system audit, quickly. Put it at IF. Appraisal. Incoming and final inspection. Now this one will be by our same Varuna. Incoming and final inspection. Bolo, what is this?
Appraisal, sir.
Now it is appraisal. Repair of customer returns. Repair of customer returns. Absolutely easy. What is it? Who will tell me? Nitish, not tell us. Nitishna, where are you? Vanished. Customer return. He has gone to give it to the customer. Suresh, what is this? He has also gone. Hariharan. Okay, anybody tell me. Repair of customer returns.
External, sir.
Absolutely external. So now, is prevention cost a total cost is how much? Add up.
$700,000.
$700,000. So is prevention greater than 10%?
Yes, sir. No, sir.
No, no. I do not know. I do not know that.
No, sir. 10% is $70,000, but only $25,000 there.
So this is not the answer.
Yes.
Internal failure greater than 70% of TQC.
Three are there.
If IF
Yes, sir. It is greater than 70% internal failure.
External failure.
Greater than 10%. External is 40,000. Greater than 20%.
So,
No, sir.
okay. Appraisal cost greater than 20%. Appraisal is 1 lakh.
1,05,000.
1 lakh, and this is 20% is
1,40,000.
so it is.
It's
the answer
not,
is
only B, sir. Internal failure is greater than 70%.
absolutely right. You are. This is how. But then it is so easy. If anybody wants to have a look at it, how it just one step more complicated. Same thing. You will find, you will start this, that is a reality. Almost it has data are from a real data, not the full real data. That is also much complicated, it looks like. But then let us see, when I got it immediately, I will show you this. That is also, first I thought to give it to you as an exercise. Then I thought it takes actually a lot of time. Okay, this one also quickly tell me. This one, very quickly tell me. But don't forget this exercise. Now you tell me this one. The percent, very quickly in this SIFI, you must tell me. The percentage of total quality cost are distributed as follows. Prevention 2%, appraisal 23%, internal failure 15%, external 60%. So your immediate recommendations will be what?
Increase prevention, sir. More money in prevention. Invest.
Absolutely right you are. Then second one, is there any second one?
We have to increase the appraisal. Audit has to be done.
Bus. Bus.
Only 2.
Absolutely best. Nothing else. When you invest more money in prevention, how can you increase external failure?
We can't increase.
You can increase internal failure. It is just a concept testing. And then this one also, very quickly tell me. Last one.
D, sir. Option D. It is fit for the intended use.
Everybody agreeing?
Yes, sir.
Okay, good. Damn good. Fine. Now we will now move on to now the slides of today. May not be able to complete the slides, but tomorrow then we will complete and we will go back to one small quiz, and then we will the rest of that, some of the tools, the fundamentals of it, we will quickly look in tomorrow. But now we are starting another the slides of today. Up till now, everybody is okay. Cost of quality, are you more or less comfortable? Srimati, are you comfortable?
Yes, sir.
Ram Vignesh?
Yes, sir.
Okay, good. All of you can see this?
Yes, sir.
Yes, sir.
Okay, good. We will not spend any time here. We have seen this. Origin of Six Sigma, Motorola developed in other companies. GV made it famous. Jack Welch is the name. Remember that name. Passed away this year. Not a very old age, but still he made it very famous. Jack Welch. Timeline not very important for us. Answer: which company pioneered the concept of Six Sigma? SIFI.
Motorola.
Motorola.
Six Sigma concept developed from here. the aeroplane landing. They always land with a sufficient, those two sides there, that if a pilot always lands within half the landing strip width, half, we say that more or less he has the Six Sigma capacity. That means these are the specifications given, and he is landing in such a manner that almost half of it clearance is there. If that be the case, it is actually it's obeying the Six Sigma statistical that curve phenomena. It is obeying. Good. We will see that again. It is this which we will try to see today. This is a very crude way of telling that when you perform in half the margin allowed to you, you may call it Six Sigma performance. Half the margin allowed to you, half the margin, tolerance are the words. If you have to park your car, where side margins are 6 inches on both sides. Both sides, there are 6 inches side margin. If your car is perfectly parked in center, what is your performance level when you find out that all the times you are able to park your car within 3 inches from the center, and at any time the side margin is not less than 3 inches? Answer is very easy answer. Answer is very easy answer. Just now we have seen.
Six Sigma.
Yes, absolutely. You have already started, 3 Sigma, 3 inches, visit 12, visit this. No, nothing like that. 6 Sigma. Leadership challenges, delighting customers. Remember this word, remember this name only, the customer delight. Maybe you have been told in your marketing class, in your such thing. It's a very famous Japanese name, his model. It is named after him. It is called his name model. I'm talking about the name starts with K. Can anybody recall? It's a Japanese name. It starts delight, customer delight. It's famous for that word, and his name starts with K. K for what? K for something, whatever it is. Kano's model. Has anybody heard about it? Kano?
No, sir.
No, sir.
No, then you have to read that Kano. Kano is now, Kano's name comes from in Six Sigma. That at least Kano's delight, that model is there. It is a famous quadrant. Anybody go back, and today that is your special. Just have a quick look on your Google, Kano's model, and understand it. It's a learning. My young friend, it's a compulsory learning, because you may everywhere you may be, oh, this guy doesn't know the Kano's model. He has never heard about it. This is the way building. So Kano's model you must know. Deklo, it is not very difficult. Yes, it is again all tangents and all those things are there, but that forget it. That is for research. You must know Kano's model, the fundamentals. Reducing cycle time. This is everybody's pain area. Cycle time, quick to market. All those things. Cycle time reduction. The Japanese companies to every company, cycle time reduction. From 4 years to, they say, a car time to market for a car can be brought down to months. Acha. So keeping up technology advances, you have to gear up to 3D printing, you have to gear up to AI, you have to gear up to all other augmented realities. All those things are very interesting, but that is technology. You have to adapt to technology. Anil, you are teaching this subjects, na?
Yes, sir. AI and additive manufacturing, all those stuff.
देखो these are the subjects: retaining people, reducing cost, response, quick response, flexibility, and a growing overseas market. This list goes on. The latest now current leadership challenge is business continuity. That's also a very, very massive subject which has grown. Business continuity or risk and resilience. How Six Sigma help in retaining people? Just try it out. Don't think it is just a simple answer. Give a simple answer. Looks like this. Because
By empowering them to solve their problems.
Three Sigma does not motivate. Six Sigma reduces stress level by empowering them to solve their problems. Which one is retaining people? People don't leave it because of this reason.
By empowering
Them to solve their problem.
Okay.
the problem.
Okay. Yes. By empowering them to solve the problem. Okay. Benefits. Several benefits. Most of it which you have seen. Sustained success. Very important. Two benefits tied to financial reporting system, customer focusing organization, full-time black belt. All these benefits are there. Quick answer. What is key purpose? Do not bother about profit. Just make customers happy. To make customers happy. To increase profit. To make customers happy and increase profit.
Third one, sir. To make customer happy and increase profits.
Okay. What can Six Sigma do? G Six Sigma economics. ठीक है, cost and benefit. ठीक है. Now this is it. This, when a company has some pain, this word, pain area, this is our pain area. This pain area word was never there before Six Sigma. Six Sigma came out with this word pain. Company's pain area. Companies, and then that is almost synonymous of that. It is an urgent thing. You have a pain, you have to treat it urgently. It's a matter of survival. So it is at the bottom. This type of pictorial demonstration you will find everywhere. So this type is famous. It started with where? It started with, now my young friends, can you recall Maslow's? This is nothing to do with Six Sigma. Maslow's hierarchy of needs. Can you recall? Exactly like this. The bottom.
Yes, sir.
At the bottom, what are there? What was there at the bottom? In Maslow?
What? Safety, sir. Safety. Safety need.
Yes, and at the top, self-actualization. ठीक है? Okay. But again, it is not that they do not Six Sigma and that is different. No, it touches everything. At the process level, that is costs out, transform growth in. These are as a process, as a philosophy, transform the organization, change the world. Okay. It's a philosophy. Okay. Anything less than ideal is an opportunity. Defect costs money. We have seen this. It's a process. Now, since it is a process, what is the process? The process is DMAIC. Okay, process is DMAIC. Very good. Its statistics. Six Sigma process will produce less than 3.4 defects per million opportunities. Process was DMAIC for statistics, 3.4. Management involvement, yes. Executives and upper management drive the effort through understanding Six Sigma. Significant financial commitments are required. Understanding Six Sigma, significant financial commitments will be required. Actively selecting projects tied to strategy. This is it. It is not small thing, very small things. No, it is not small improvement. It is not, Six Sigma is not say, let us say, in a company, it is suppose karo ki a swinging door is creating problem. So change the swinging door into something in a more better type of a door. That is also something. It is, but it is a small thing. It is not. It's nothing connected with strategy. So those are not Six Sigma projects. It is not even the quality control QCC project. QCC project is known as quality circle projects. It is a larger frame these projects. It sometimes will call for drastic change in process. It sometimes will call for totally remove several of the process. It may call for looking at such a designing such an experiment and then proving it to be beneficial that you completely change the whole thing. It is such strategic as this is related. In one go, you will find that the product's competitiveness goes 10 times more than your nearest competitor. So those are related with strategy. Setting up formal review process, selecting champions. Okay. You know this.
3.4.
And what are the key issues in leadership? How will leadership organize to support Six Sigma? What will be the structure, organization structure? Does it need a structure for supporting? Does it need transition rate to achieve? Level of resource commitment? These are all leadership key issues for leadership. Okay. Only know this. Just know this. Everywhere you will find this. These are all the summaries as if they have been put. Extremely important moment you enter a company, and you have to understand all. You have to keep in your mind all these things. You can't say no, sir. These are I do not know. These are nothing like that. No. Now we spend 2 minutes here. Philosophy of Six Sigma is know what's important to the customer, reduce defects, center around target, reduce variation. There are 4 almost CTQ, Dpmo, mean, SD. SD Burman. SD. Have you heard of this name, SD Burman? No, you have not heard.
Yes, sir. Yes.
You have heard. My young friends, have anyone of you heard SD Burman?
Oh, sir.
He was an extremely famous music director. All Hindi songs and several other songs are all from this band, SD.
Sir, this generation will understand R.D. Burman.
For them, that might also be, many will also not know him. You know R.D. Burman. I think my young friends, you know R.D. Burman? His father was S.D. Burman. Okay, these are words. What is CTQ? Can anybody tell me quickly? What could be CTQ? I am giving you clue. Critical. Eh?
Cost to quality, sir.
No. Critical to quality.
Okay.
See, it is strategy. It is strategy. You touch upon those areas which is critical to quality. That is why they say it is strategy. Changing a door is not a customer's worry. So, customer worry is, give me a classical example of critical to quality. Take the example of, now my young friends, how many of you, honestly tell me, how many of you have got motorbikes? Somebody must tell me, or none of you have motorbikes, then that I cannot believe.
I don't have, sir.
I have motorbike.
Yeah, somebody will have, na? So let that somebody say, sir, I have a motorbike.
I have, sir.
Who have it? What's your name?
Sudarshan.
Sudarshan. Now Sudarshan, tell us, what in a motorbike as a customer, what is critical to quality? What do you want in a motorbike? Which is most critical parameter for you?
Mileage. Mileage.
Mileage means express it, give a better expression. Mileage means
It's a amount of fuel consumed per the distance traveled. How much fuel has
in simple terms, kilometers per
liter.
bus. So this is a critical to quality. You want this to be now with you as a customer. The company must find out what is the figure which you are looking at. Not only you, large number of yous. That is why they conduct survey, and this is critical to quality. A second thing critical to quality suppose karo in a automobile in a automobile. Now Srimati will tell us in an automobile that also kilometers per liter is important, but another important feature in an automobile, Srimati. Quickly. Okay, pass. Kalai Selvi. You are also pass. So, Praveen, are you there? All quiet. Okay, anybody?
Less maintenance cost.
Besides kilometers per fuel,
Less maintenance.
What?
Less maintenance cost.
Maintenance cost, okay, but you really okay.
The thing is, next important thing is comfort, sir. Comfort is required.
Comfort, but you will not be able to express comfort. That also is difficult. But yes, comfort. Everybody is designing cars with comfort. It will tell you many things. But then translate.
The
Safety
model and
features.
design of the product.
Safety features, sir.
You know another
The model
feature.
and, the model and design of the product, sir.
Yeah, this is a absolute thoroughly interesting exercise goes on. Not fun, but we are. This exercise itself takes at least half a day, and then you come out with how you determine parameters. It is so exciting. But then, chalo, the tools have their approaches. This is not a perfect tool. This is an approach. It is known as house of quality. And the Japanese and all other companies, they rigorously practice this tool. But now I'm saying, if you go to a car company and they are showing it, taking you around the tour, usually they will not take you to one Actually, they have many restrictions. Just like that, you cannot enter a car company. Even on your, suppose you are from the, say, you are a company, they have many restrictions because they are afraid in business. You will see things, and then you will, if you are a competitor, you will see things and you will translate it back into your own company. But they have certain areas they are very restricted. One of them is, now remember, one of them is painting. Why? Because
Paint booth, color combination.
The paint is a critical to quality. Critical to quality. Oh, you know, there is that joke is there. That joke was there that when you get married, and then they give you a car, and then they say, okay, we will give you a Maruti car, and then the groom to be then silently says, I need a real red Maruti car. So that red is that key. Yes, the color has got so much of appeal to a customer, to a buyer. So this is how the critical to quality is the most important. First thing is critical to quality. The second thing is in Six Sigma is Dpmo, the effects per million opportunities which we have seen. The third thing is centering around the mean, centering around the average, centering around. That is the mean, hit the target, hit. That is the concept. And the last is both mean and then this concept, reduce the variation. If there is a variation, then life is not a very enjoyable thing. Customers are do not enjoy variation. So these are the four main philosophies or the concepts on which Six Sigma is standing. Okay, this is the funda of this fund. Today's funda starts now. Critical elements: genuine focus on customer, data and fact-driven management. Data and fact-driven management. Process focus, proactive management, collaboration, boundaryless collaboration. Boundaryless collaboration means a very tough word which immediately my young friends will not appreciate, but remember, boundaryless, that means boundaries are between production, and supply, store, between production and inspection or the quality, between quality and materials, between this and that, and between company and service department, between company and supplier, between company and the dealer, like that. So boundaryless collaboration is the word, collaboration. As you see, because it is needed. This is a strategy area. The strategies are built around this. So there are many deviations. So to remove those deviations, remove those defects. Try for perfection. Tolerance for failure. Now, data-driven decision. Y is equal to fx. Y is output and Y dependent. X are independent. Y is dependent on X. Output, input. Effect. The cause and effect relationship. Y is equal to Fx. The symptoms. There is a problem there. So problem giving rise to symptoms. Controls. You need to monitor the controls. So Y is equal to Fx. Data-driven the decision. True process. You remember, Six Sigma is a statistics 3.4. Six Sigma is a process, DMAIC. There is another process, DMADB. This is for new process, and DFS is designed for Six Sigma. Define, measure, analyze, design, and verify. Okay. Okay. Tell me this. Praveen, tell me. Suresh. Tilakraj. All are opting to remain quiet.
Fever, sir.
Viral infection.
Sure.
No.
X is, which of this is X?
Viral infection, sir.
Fever, sir.
Good.
Headaches.
Good. Good.
Fever, sir. Yeah.
Hey, even nahi. Viral inspection.
Viral
Yes.
infection. Okay.
When it is there, then you have fever. When it is there, then you have headache. When it is there, then you have cough.
Sir, then the question should be, what is Y, sir? Because due to viral infection, these three are having.
Which of this is X? This is the tricky part of it. The question, look at it, the question. In the representation of Y is equal to Fx, which of this is X? It is not telling you like that. Okay, they say. Some of them can be Y, some of them can be X. So he is telling you what can be, if this is there, what is X? Which one is X? That is why to make you think. Also, I also thought like you first. Then I realized, oh, these guys are intelligent. That is why they are asking this way. Okay, chalo, good. But remember this. This is how. Yes, not a very simple thing. They put it like that. Okay. Now you have seen this. We are not going to spend any time on this. These are the iceberg concepts, and these are all the hidden cost. All these setup, typical thing. Setup. Huge time it takes. Huge cost is involved. Late delivery. Lost customer loyalty. Large cycle time. Terrible things. Terrible things. COPQ and Six Sigma level. From there to there. Imagine the amount of money that is saved. Tell me.
Cost of raw materials.
Cost of inspections.
Cost of
Which of
repair.
the following is not the cost of poor quality?
Cost of inspection.
Cost of raw
Inspection.
materials.
Cost of raw materials, sir.
Your voice is telling that this has to be the answer, and that is the answer. Not this. Not
Cost
this.
of inspections.
No, only this. Only this. Hey, who was that? Cost of raw material. Who said? Name.
Cost of repair.
No. Answer is which of the
Cost of inspections.
only answer is this.
Cost of raw.
Cost of raw material is what has got to do with the cost of poor quality. When something has happened, then something has happened, customer law. Oh. Process. This also we have seen input, process, output, and then we had said our outcome and like that. CTQ. Critical to quality. Don't forget CTQ. CTQ characteristic for the process, service, or product. You are, you are, you have gone to the passport department. You need the passport. You are a customer. For the passport department, or you as a customer, what are the city queues? Don't give me wrong answer. Young friends, don't give me wrong answer. What are the city queues for you as a customer to the passport, for the passport department? Passport department will must now know city queues. So tell
Waiting
me.
time. Waiting time.
Okay, that is waiting time for what?
To take the application, processing time. Standing in queue, we should not be idle there when get there. How fast we are getting service?
One is if you, because you have to clear your mind. Now, waiting time means if you are standing in queue, there is a waiting time.
Yes.
But if you say cycle time, the total time it takes for you to, for them to process your request, and you have made the request, time starts now.
Yeah.
You have got the passport, time ends then. That is also another city queue.
Yes.
So that is city queue. The one
And
which you said, that is also city queue, and
there should be no mistakes in the document. What
that
there
is
are.
it. Those are all city queues. You know, passport department, who
Verification details,
that is another, but verification details is not, you are not sharpened your statement. What is the city queue? Is it mistake, or is it time, or is it something else? Therefore, you have to be very clear. In the passport department now are much better, 1,000 times better. Who did that thing? That software and other things, everything was developed by whom?
TCS, sir.
And they wanted that whole process to be Six Sigma. Remember this. And they did it. They trained a large number of Six Sigma people. That way back in the 2000s, they started doing the entire thing. This is how it happens. Okay. No. That we have seen. Measure of what is important to customer. Waiting time in a clinic. In a letter. Percentage of valves in an in my process. Every process has Ah, can you now hear me?
Yes, sir.
Connectivity gone. Tuck, say. Okay. Problem. Come on, let me bring that. Yes, now is it visible?
Yes, sir.
Yes.
Okay. So, critical to quality related to, what is the answer?
The needs of customer.
The needs of customer.
The
Absolutely.
needs of customers, sir.
Yes, not the specified requirement. Requirement also, the specific requirement is this, like that. No, in this, if there is a choice between two, it is this. Then with the specified requirement also, which is the whole thing is actually specified requirement we will find. But still, the answer is no. It is the need of the customer. Okay. Defect opportunities now. Very quickly, you have to tell me. This you know, in which circumstances in which CTQs can fall. Complex unit, okay. Unit has 5 parts, each part has 3 opportunities. So for defects, defect opportunities 15, no issue here. Number of defects divided by the number of, so defects per unit, this much. Dpo, this much. Dpmo, how much will you Dpmo into 10 to the power 6? How much is the, will it lead to? 1, 3, very clear.
143, sir. 13,333 points.
Okay. 13,333, which is equal to near around that. You take that table and it is 3.7 sigma, near around that,
Yes.
which we know.
Yeah.
Now, only conceptually tell me this. Only conceptually, you are playing, you are shooting a rifle or doing this thing. This is an interesting area, but then will not. Yeah. Now, who is better, bolo to?
Jim.
Jack.
Jim, sir.
Why not Jack?
Jack is nearer to mean, but he doesn't have repeatability. His variation is very high, but he has a Jim has only shift, but he was accurate. Accuracy is more for Jim.
Accuracy is more for Jim or for Jack?
Jack, sir.
Jack, sir. Accuracy is more for Jack.
But whom do you, suppose you want out of them, whom will you like to give the responsibility after training, of course? Now you want to train them up. Whom will you choose and why?
I will choose Jim, sir.
Everybody will choose Jim or somebody will choose Jack?
No, sir. I would
Jack,
choose
sir.
Jack because he is close to the
Jack, sir.
target.
No, sir. I will choose Jim.
Dekha. Think about it.
Sir, because for Jim, I can rectify his error by training because he is repeatedly hitting the target at same location. That's why I choose Jim.
You have a very
It's my perception.
you have a very good perception. Not only perception, you have a very good observation. Because perception comes from observation. Good. But there also our friend is saying, "Toing," as he has Jack has it. This is interesting. I will just keep that in frame. We will variability. Keep that in frame, and we will try to and read it up later on. And then deviation is equal to distance between observation and the mean. Okay. variability. Just have a look at it. These are average is 8.4. Jack situation. Variability, Jack. And variance, deviation, square the deviation, and then how do we arrive at 1? ठीक है. This is Jim. His variance is this. His was this. Just keep this in mind. And now, from there, it is 4:40. Only for 10 minutes, be very attentively listen. If I've got a great deal of numbers, suppose I am measuring something and plus minus 50 plus minus 0.05, and I am taking readings 50.01, 50.06, 49.02, 48, like that. 50 readings I have got. And if this frequency plotting, if I do, every possibility that I will get a figure somewhat like this. This. Plotting frequency distribution. This is the shape which comes out is now known as normal curve. Most outcomes occur in the middle. That means here, this is the average. Most outcome occur in the middle. And then this is how the tail, fewer in the tails, lower, fewer in the tails, and even very rare outcomes are possible, even very rare on this part. This is normal curve. This is property of a normal curve. Very vaguely you may recall that this is known as mu. You can also put it as x mean plus minus 1 mu is area under this curve is 68% area. Beyond this plus minus 2, what is written here is, देखो, this is a shape. This shape has to be described. The way it has to be described is, what is the central tendency? That figures have got a 50.1, 50.2, 50 numbers. There is a sample. This is a sample concept. So, the central tendency is, what is the tendency? Central tendency. There are the measures are mean and And another one is, what is the spread? Spread is that the highest minus the lowest. This is the highest number. 50, let us say that 51 was the highest, and let us say 49 was the lowest. So these are all the values are in between. So that is the spread. That is known as range, and this is known as average or the mean. Average and mean. Besides these two, there is one more parameter is there. That is describing the shape. This is this parameter. This is this parameter. This parameter is nothing but this distance is this distance, this distance. This is how one shape is there. So this shape, and suppose there is another shape, it starts from same place and it goes like this and this and this and this. This is how, and it touches this and then it is like this. The range is same, the average is same, but the shape is different. This difference is it is, how do we express that? That is known as standard deviation. That is known as standard deviation. So that is known as 1 sigma. 68% are in this. This is the property. 68% area is okay. Is okay. That is how you try to remember. So what is not okay? This portion and this portion is not okay. 28, and here if it is 2 sigma level, it is 95%. If it is 3 sigma level, this is 3 sigma level. This is 99.7 and rather 99.73%. Only tell me, anybody can tell me who has a little who is having a perception. Okay, 4 sigma will look like what? Just keep on thinking. 5 sigma will look like what? Because you're saying here 1, 2, 3. Keep that in your mind. There are 2 reasons. Keep that in your mind, because I told you now for 10-15 minutes only. Keep that here. There are 2 things which happen in the cause of variability. One is common cause. It is common cause.
Rudy,
Pardon me? Okay, common cause. Random variation within predictable range. No pattern. Inherent in process. We are not very much bothered initially in the common causes. We always bothered about special causes. Something non-random. Something that exhibits a pattern. This is where the 6 sigma play starts. This is where it touches here and then later on it goes here. So we want to reduce variation. We want to remove all the special causes. Why? What do we achieve? Then there are two concepts are there. One is specification limit, another one is process limit. Only listen to me what I am saying. Every process has got a limit. Every process, that limit is set by whom? By that machine, by that raw material. All those things set the limit. In a human body, everything has a limit. I have a limitation of eating so much. Determined by what? Determined by my age. Determined by the kind of a physical fitness which I've got. I may have so much of rice, so much of this thing. Beyond that, not possible. And maybe Anil will be a little bit more than me, maybe, or maybe less than me. That is his process limit. This is his process limit. This is different from specification. Specification means somebody tells you to make something within plus minus this. Your machine, your material is unable to has some limit because that is your process limit. Somebody comes and tell me you have to eat this much. No, not possible for me. So these 2 things are absolutely different. Plus minus 3 sigma, 1 sigma, 2 sigma are all our process limits. So H2 plus minus 3 sigma, 99.373% are all process limits. It's the most important fundamentals in 6 sigma. How does it look like? This is actually the whole scenario, something like this. If you only you know, now see, same thing, one thing here, देखो, either the mean is here, the mean is here, the mean is here. Your USL means specification. This is specification. Who gives this? Customer gives this. Design develops this. So your this is the lower specification. This is the lower. This is the upper. Same as this lower upper. This portion is non-conforming. This portion out. This portion non-conforming. This portion non-conforming. This portion non-conforming. And here, only tell me. Anybody tell me which is that out of these three figures, which figure will give me zero non-conformance? A, B,
Large
C.
variation, sir.
A, B,
Large
C.
variation.
Which one? Out of A, B, C.
Large variation.
This is A, this is B, this is C. Which figure will give me zero non-conformance?
B, sir.
C.
B.
Did you say C? C for coaching.
B, sir.
No, this is non-conformance. देखो स्पेसिफिकेशन से बाहर भी गया है, स्पेसिफिकेशंस का outside it has gone, whereas here look at the specification, it is here the process is, your process limit is this much, which is well within your USL LSL. Here again your process limit is just touching the USL, and this process is touching your USL, but your LSL mein there are defects here, whereas here this and these are defects. Here this is defect, this portion is defect. Here all are within. This is the fundamental Six Sigma. This is how you push pull it. See another this thing. Now here, poor quality, this is defect, this is defect. Your process limit is here. Yes, your upper specification is here. So defect. And here your LSL is here, your USL is here. Your process gives you all within it. So there is a huge margin. The plain landing margin. This is the plain landing margin. So in this case, this is how, when your process limits are less than your specification limit, then the chances of your defects are very less. This is how isko bolta hai. This is how the fit, this is how the Six Sigma looks. Actually now how does it look like? Phew, this is how it looks like. You had said Six Sigma. So dekho what it is written. It is, this is how 1, 2, 3, this is 1 sigma, another 1 sigma, slice, 12. It is 12. This whole thing is, if you start from here, this side is 6, this side is 6. This is how the Six Sigma word has come. This is how 3.4. And how does this look like? And this is how it is, perfect position. It is just stable. It is stable. Whereas if it's if it is stable, this is your upper process limit. This is your lower process limit. How do I get lower process and upper process? This is from that 3 plus minus 3 sigma. What is this distance? This distance is 3 sigma plus. This distance is 3 sigma minus this side. This is what is this point. This is the mean. This is the average. And when you this is how the control charts are, which is the fundamental thing, how control charts are built. These control charts are everywhere. Automated control charts, even in the medical science, you will find pip. This is automated control charts everywhere. And when there is a little, this is process is never stable. I can never say ki I will have so much of rice, so much of this thing. There will be some shifting. The shift that is considered is this is the typical stable process. So much of playground is there. Tomorrow, if possible, I will try to see whether I have that chart or not. Then you will immediately realize what I am trying to say. That is actually the playground concept. So that how much space I have to play. That is where the Six Sigma started developing. And if I shift little bit, the shift that is considered is 1.5 sigma shift, and then that shift considered करके process shift allowed 1.5, and we have this. This is how the whole thing looks like, and 1 point shifting, say. I know this is little, you need some time. This is even you read that book, and then again tomorrow we have some time. We will again look into this in if possible. With that other example, I will tomorrow spend some 15 minutes to 20 minutes. That should be enough, so that you can make out this shape and what does that Six Sigma is actually trying to say. Moving ahead, components of Six Sigma, process power and people power. This is DMAC. Don't have to look at all this thing. Define what is important, what is DMAC in the easiest form. Define what is important, what is measure, how are we doing, measure, evaluate, take a status, take a stock of the situation, analyze what is wrong, improve, fix what is wrong, control, ensure gains and maintain to guarantee performance, or else you will slip down. This is the fundamental of DMAC. And their approach is, again, define the customer, they are critical to quality issues. They are critical to quality. Measure the performance of the core business process involved. Analyze the data collected. Improve the target process. Control improvements to keep the process sustained. That is, this is sustained. Why should there be a control phase when improvement is already done? Give me the right answer.
This is to maintain the gains.
Absolutely. Absolutely. We stop here today. Tomorrow we will cover this few more slides which is there. Not many are left. Define and or this thing. And if possible, if you have time, max time, if you have got some 20 minutes, try those 20 questions, which I think, Professor Datta, you have already circulated them.
Yes, sir. Quiz 2.
So this quiz 2, try them out. Just for the if you and then because we want to finish it in 10 minutes, then I will move on to just to help you to understand those, that curve which has come out and the essence of Six Sigma. That is, here it is interesting. The funda is you have seen 1 sigma 6,90,000 to funnel 6 sigma
3.4 Dpmo.
Yes, and when that actually is actually that is Hey Joe, now, if you in a plus minus 3 sigma, remember there is one thing you must remember. This is a very typical normal curve. Where does this curve go? How far does this curve go here? How far does this curve go here? It goes infinity in both directions. It does not, it never touches it. Fine. This is the fundamental property. How does engineers or technical people and managers looked at it? They looked at it that how far can we go? This is stable. In a stable process, they said we can go up to this level. When you go at this level, there is something more remaining there, something more remaining there, something more remaining here, because it is infinity. Even if you go at that level, that means in this side, this is 1 sigma, this is 2 sigma, this is 3 sigma. Therefore, this is how much? 4 sigma. This is how much? How much? If this is 4 sigma, this is how much?
5 sigma.
5 sigma. This is how much?
6 sigma.
This is the concept of 6 sigma. And on this side also there is 6 sigma. Therefore, total is how much? 6 plus 6?
12 sigma.
12 sigma. This is, but even if you go up till this and then it is going there, it is going there. There is, and this portion, whatever is going there is the non-conforming defect. There is the defect still remaining. Yes, defect still remains. When this is stable, this is stable. When it is still remaining, how much is remaining? Statistics is a wonderful subject. The remaining portion here is 1. The remaining portion here is 1. So it makes 1 plus 1 how much? 2. But it is no longer million. It goes up to billion.
Billion.
2 billion. When there is no shift, perfectly stable, a process is perfectly stable. This is not possible. Therefore, they said let there be some shifting take place. How much shift they allow? Where from they got all this 1.5? We are not going to discuss that. But remember, there is a 1.5 deviation. If there is a shift on this side or on this side, then the value jumps so much that from billion it comes to million, and from 1 it comes to 3.4 divided by 2, 1.7. One side, 1.7, another side. And therefore, that makes it 3.4 parts per billion. This is the fundamental 6 sigma. When you say it is 6 sigma, it is this picture which is actually, it should come into your mind. This is the 6 sigma. And a little bit of shifting means that these two figures should come. This is why it is called 6 sigma. No other, if somebody asks, what is 6 sigma? Then this is the figure, and this is 6 sigma one side, 6 sigma one another side. I stop here because it is 5:02. Tomorrow, again, we start. We will, please do that. 10 minutes, we will finish it. However, mostly, again, I will just with that simplest of the simple example. There can be any, no example can be more simpler than that. But hopefully, we will understand this concept. If we understand it, well, my job is over. Today, I know this is little tough, and then the rest of it is DMAC. What is DMAC and what are the tools associated with it? We will have a look, and then you read up, because he has given you, Professor Datta has given you a very good book. Read that book. A set of slides are also there. You will start understanding those slides. But read that book. It's a very good book. I know you will not, reading is almost impossible, but these slides you try to remember. Let us see how you can access these slides. We will have a discussion with Datta, Professor Datta. And so thank you so much. But try out those quiz, because now most of the quiz I think you will be able to do in a jiffy with this knowledge. But don't forget this knowledge. So thank you so much. Again, we meet tomorrow. It is 5:03. Any questions right at this moment? Ask me, or keep that in mind. As we call it, park in a lot. parking lot में रखो, and then tomorrow, first thing we will do if there is any question. Questions like, okay, you don't have to think now. Okay, Professor Datta, I am through, and you can close the session. Okay.
Yes, sir. Thank you, Ravi, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you.